Welcome to all of you Woodrow Wilson Academy of Engineering geniuses, whenever and wherever it is that you find yourself taking a look at this screencast. This is Mr. Garrison, and I am preparing for you exclusively this short review via screencast of this very short and limited selection of test questions that Project Lead the Way has released as a preview of the type of questions that you should expect to see on this end of course exam. The exam once again will feature 61 excuse me 61 total questions, and you will have those given in two sections of 40 minutes each, so you will have 80 minutes to answer these total of 61 questions. And this particular quiz has just 5 questions, and I'm going to use this opportunity to walk through a couple of test taking strategies that I really believe will be helpful. Over the years, I've, for a lot of reasons, gotten to be really good at taking, and not just taking, but passing with really high scores tests. And so I'll share my thinking with you in hopes that some of that might be helpful. And then, secondly, I also want to just share my thinking out loud as I answer each question to give you some insight as to how you might go about um, reading and answering these types of questions. You would want to have your Project Lead the Way reference and formula sheet handy, and we'll take a look at that shortly. Right, so this is a simple 5 question sample, and I am going to now take this quiz as you will yourself, or you should have already. So when I see these questions or any selection of questions, I first want to go through and scan each question and in my mind make a quick categorizing of each question into kind of easy, medium, or hard. And then my thinking goes like this. I want to tackle the easy questions first so that I can warm up my brain, get some momentum going, and not put myself in some emotional tailspin or spin cycle where I start worrying about how I'm going to do on any given test. Once I answer some easy questions, I'll start gaining some confidence and remembering some things that I may be able to use on other questions. And I furthermore don't waste any time on harder questions that I'm not quite ready for. My thinking, my thinking goes, if I am going to, let's put it back here on the quiz, if I am going to need extra time, it would likely be wiser to have that time be available on the harder questions. Plus, by the time I've answered a number of questions correctly in my own mind, I will have gained some confidence to tackle the harder questions. So I'm going to look at this first question and say this is a question about electricity and circuits. Um, Not sure if that's, I'm going to put this in the medium category. It has possibly some calculations. Then I come down here to number 2. It's asking me to identify what part of the design process. I think that goes in the easy category. Question number 3 here. This is simply asking you to understand how to use a decision matrix. I personally think that is also in the easy category. Some of you might put it in the medium category, but it's certainly not difficult. This question number 4 is certainly in the easy category. This is simply a recall question asking to identify what type of lever this is. And I know in my mind I can go to the reference sheet and look quite quickly at the last page right here and look at these 3 types of levers, first, second, and third class, and basically match up the picture with which type of lever am I looking at. Then I can answer that question. Now here, I don't have a reference like this in my reference chart, meaning this stress strain curve. So I would put this in the medium, and some of you might think it belongs in the difficult category. I put it in the medium category. So let's go through these one at a time. There's your test taking strategy, at least one of them. Categorize the questions, answer the easy ones first, then do the medium ones, and save the difficult ones for last when you have more time and you gain some confidence. So this first question, as you see, an engineer must design a control panel for a wind turbine. So this is asking about a design. This is presumably a design question, and it gives me the constraints right here. 2 warning lamps turn on when the turbine speed exceeds 5,000 RPMs. That's this component here. Here are my 2 lamps, L1 and L2. These are lights, warning lights that both have, I notice, the same resistance. Then my second constraint tells me if the current through either lamp is stopped, meaning one burns out, the other lamp must still be able to illuminate. That triggers in my mind uh, a parallel circuit. That is the only kind of circuit you can design where this would be true. Third constraint here, the total current must not exceed half an amp. Now that might require a calculation. So here's the question, and it's always best to read the question and not make assumptions about what the question is asking you for. What design satisfies all of the engineer's design criteria? So I'd take a look at my 3 schematics here and notice I have a series circuit and a second series circuit, and down here a parallel circuit. Right away I know that these 2 series circuits cannot satisfy constraint number 2. Therefore, I have to do no calculating, and I can easily choose answer number 3 and be confident that without even doing any math around constraint number 3, that this is your correct response. All right, we are going to move on to question 2, which asks us to evaluate 3 students who are designing a winch system. Part of their design process, they find existing solutions and identify why the solutions are not adequate or appropriate before they go about creating their own design. So they first must do some research, and let's look at the 4 choices: develop a solution, testing results, research and define the problem, or evaluate the solution. This can be a little tricky because it sounds like they're testing solutions, or maybe they're already developing solutions, but they haven't defined that. You cannot define what the problem is until you know whether it's been solved or not. So they're looking at existing solutions and finding out whether they're adequate or not, and if not, why not. So this comes fairly early in the design process. They're not yet developing a solution. They're clearly not presenting testing results. That comes very late in the process. And they are also not evaluating the solution because they don't have one yet. So the only choice I'm left with is that they are researching and defining the problem before they move on to developing a solution and then evaluating the solution and then presenting test results. If you weren't sure about the order of those, you should have a copy of the design process in your engineering notebook, and you can refer to that. But this should be and will be our correct response. Now we can move on to looking at question number 3, which asks us to evaluate a decision matrix against this 4-point scale, 4 being excellent, 1 is poor. There are 6 ideas that I'm going to evaluate against 3 constraints: cost, complexity, and development time. And then what I need to know in order to use a decision matrix is, once I've totaled these up, after I've evaluated each constraint in each idea, I will total these up, choose the biggest number, and that should help me choose the best idea to pursue to begin with. This helps take out some of the bias that comes with engineering decision making, because our opinion is not going to be completely accurate. So clearly 11 is highest in this total column. That brings me to idea number 6. So I come down to make sure that that matches up with the answer they give me. Number 6, since it ranks highest on the decision matrix summary, I choose that, and then notice that idea number 4, since it has the least complex, well, that's just one criteria. Number 3, since it has the highest decision matrix total, well, let's go see if that's true. No, 11 is higher than 10, at least in this universe. Number 2, since it has the lowest cost, where is that? Well, according to this, that's not even true. the most excellent choice would have been number 5 or number 3, according to this cost constraint. So this last answer is not accurate either. So I'm confident in that. I can move on and notice that number 4 is asking me about a simple machine. What type of simple machine is a shovel? And I know I can easily go to my PLTW reference chart where I have a picture, diagrams, and all the associated uh, formulas necessary to evaluate simple machines. And I can go back to my question and note that, oh, I see a fulcrum with the effort force between the resistance and the fulcrum. All I really have to do is go match it up with my 3 pictures. Only the second and third class levers have a fulcrum on the end, so it must be one of these two. And I notice that my effort force here is between the resistance and the fulcrum, so clearly the only right answer is a third class lever. Click that and move on with confidence. Now, this last question, which might be the most difficult of these 5 questions, I simply have to remember how to evaluate a stress-strain curve. Stress on the y-axis, strain here on the x-axis. Stress is a force or a load applied to a material that causes strain, which is a stretching or an elongating of that particular material sample. Now I have 4 points. The question wants to know which point is in the elastic region. And if you remember, in our work with trusses and truss simulators, and building our own trusses, we evaluated stress strain curves, and note that there are 2 major reasons. Here we have this curve range, which represents the inelastic region, and we also have this linear region here between A back to the y-axis and between the origin and A is linear. You might note there's a line and then we have a curve. This line represents the elastic region where if we remove the stress, the strain would then be reduced and the material would return to its original size. After point A, we have stressed the material beyond its point of returning to its original size, and then we see it continuing to stretch until it finally gets past point D where we can assume, breaks. So our choice is only point A. And if we submit this, we should. So we have submitted this quiz, and yes, we see that we're 5 for 5. And this time limit was set for, I think, 7 minutes, which is approximately the amount of time you'd have in a proportion for these 5 questions. With the 61 questions on this end of course exam and the 80 minutes it take you to have approximately 1 minute and maybe 20 seconds or so. So you want to understand that you're under a time constraint, which again puts the premium on making sure that you have a test taking strategy that helps you use your time wisely. So hopefully this was helpful. There'll be other screencasts to accompany these other quizzes along the way. Hope this is helpful. See you next time.